Today we're going on a bug hunt. And no, not for insects, but for those tiny, hidden flaws in software that can cause just massive problems. We're about to dive into some really fascinating research that introduces a new kind of super sleuth for finding these digital dangers. So I want you to imagine you're a developer for a second. An automated tool scans your app, and it comes back with this: 896 potential security alerts. And that's not some made-up number. It's what one tool found in a real project called GPAC. So now it's your job to sift through all of that and figure out what's a real threat and what's just noise. It's the classic needle in a haystack problem, and it's absolutely overwhelming developers everywhere. All right, so here's our game plan. First, we're going to tackle this phantom bug problem. Then we'll look at the old way of hunting them down. After that, we'll meet our hero, this new tool called Lyso, and see how it follows the clues. And finally, we'll check out its seriously impressive results and talk about why any of this really matters. To really get what's going on here, we have to start with this phantom bug problem. See, the very tools that are supposed to help us secure our software are, kind of ironically, creating a huge amount of noise. These tools are called static analyzers, and they're essential, don't get me wrong. They're like robot code reviewers that read through millions of lines of code to spot patterns that might be a vulnerability. The problem is that word might. They flag anything that could be a problem, which, as you can imagine, leads to just a flood of alerts. And hey, don't just take my word for it. As the researchers behind this work put it, the burden of manually checking every single one of those issues is a massive drain on time and resources. You have developers spending their days chasing ghosts instead of actually building better, safer software. Okay, so to sort the real bugs from all those false alarms, we have another set of tools: fuzzers. You can think of them as the first generation of bug detectives. They've got their methods, for sure, but as we're about to see, they also have their limits. So the main technique here is called directed Greybox fuzzing, or DGF. It's a mouthful, I know, but the idea is actually pretty simple. Think of it like stress testing a very specific spot on a bridge. You give the fuzzer a target, a potential bug, and it just starts throwing all kinds of data at the program, trying to make it crash right at that exact spot. If it crashes, boom, you've confirmed a real bug. But here's the thing about these old school detectives: they have some serious blind spots. First off, they're lone wolves. They can only hunt for one target at a time. Second, they've got tunnel vision. They only see the finish line, that final bug location, and they don't really care how they get there. And because of that, they completely miss the bigger picture. They can't see how different alarms might actually be connected. And this is where our story gets really, really cool. To get past all those limitations, the researchers built a brand new tool, a new kind of bug detective. Its name is Lyso. Lyso is built on a couple of really powerful what-if questions. First one, what if, instead of just chasing one bug at a time, a tool could see that several alarms are all related and hunt them down as a group? And here's the second big idea. What if the tool didn't just blindly aim for the final crash site? What if it could follow a very specific sequence of steps, like a trail of breadcrumbs left by the analyzer, to trigger those really complex, hard-to-find bugs? So here's the side-by-side, and this is really the key. While those traditional fuzzers act like lone detectives, Lyso runs a whole coordinated investigation. The researchers have fancy names for this. Its multi-target ability is intra-target directness, and its step-by-step guidance is intra-target directness. But really, it's a fundamentally smarter way to hunt. And that multi-target approach, it's not just some neat trick. It is absolutely essential. The researchers actually analyzed a bunch of software and found that nearly a third, 31%, of all true security bugs were interdependent. They shared a common root cause. If you ignore those connections, you're leaving a massive blind spot in your security. Okay, so that's the theory, but let's see this super sleuth in action. The paper gives this fantastic example of a really tricky bug that other fuzzers just could not crack. The case is called TIF009. It's what's known as a null pointer dereference, which is a super common but also super serious bug where a program tries to use a piece of memory that's empty and then crashes. But here's the catch. You can't trigger it just by reaching the last line of code. Nope. You have to follow a very specific sequence of events to even make the program vulnerable in the first place. And this is where Lyso's method is just brilliant. First, it analyzes the connections and sees that TIF009 is related to two other bugs. That helps it prioritize the search.
Then it follows the step-by-step map. It knows it has to hit this one key clue, a specific line of code that sets a variable to null. By following that exact path, it corners the bug and bam, case closed. It triggers the crash. Other tools, they just aim for the end, completely missing that crucial step. They'd never find this. So that's the theory, but what about the proof? Did it actually work? Oh yeah, the results are, well, they're pretty staggering, honestly. Lyso was put up against other state-of-the-art tools, and here's what they found.
The headline number is just wow. On average, Lyso found bugs over 12 times faster than its competitors. This isn't just a small improvement, we're talking about a massive leap forward in efficiency.
And this chart really tells the story. Over a 24-hour fuzzing campaign, you can see Lyso, that's the highest bar, just steadily finding more and more unique bugs. Meanwhile, other really powerful fuzzers like Titan and AFL-Go, they find a few and then they just sort of plateau. Lyso's smarter approach means it just keeps on digging and keeps on finding more.
And this isn't just about winning benchmarks in a lab. The researchers turned Lyso loose on 4 well-tested, real-world programs. It discovered 18 new, previously unknown vulnerabilities. I mean, these are bugs hiding in plain sight in software people use every single day. 7 of them were so serious, they were given official CVE IDs, which are basically public warnings for known security flaws.
So, at the end of the day, why does a smarter bug hunting tool matter to you? Well, because the lines of code it's analyzing are running everywhere, from our phones to our cars to the power grid. The impact here is really threefold. First, and most obviously, it means safer software for all of us. Fewer bugs means our data and our devices are just better protected. Second, it makes developers way more efficient. By automatically confirming which alarms are real, tools like Lyso free up brilliant human minds to solve bigger problems. And finally, this research points towards a more secure future, paving the way for even more advanced security tools down the road.
Which leaves us with this one last really fascinating question. You see, for years, the big bottleneck was just confirming which bugs were real. Now that a tool like Lyso can do that with incredible speed and accuracy, the whole game changes. So the next great challenge, it might not be finding bugs, but automatically fixing them. And that is a future worth getting pretty excited about.